What I want to do in this video is explain some things about lighting and then show you a technique that I've come up with to overcome some of the problems I'm going to explain. So as things stand, this is default Bryce lighting, and these three objects have each got 15 reflection. So there's a very simple material setup here, default grey plus 15 reflection. What you'll notice in this render under the default Bryce sky, or what I hope you'll notice, is that where the sun is just here, that's actually a reflection of the sun. The sun's not very bright. Now, you would expect the sun, being a tremendously bright object in the sky, would reflect a bit more than that on the surface of this object. And it should, in reality, but that's one of the limitations of Bryce lighting in its default state. To overcome this drawback, I can show you how you can just quickly and simply make these things look a bit more realistic. Under this setup, you can introduce a specular highlight, but it's quite difficult to get the size of this specular highlight down to a size where it would look appropriate for the sun in a scene. So now we've got a highlight, as you might anticipate a very bright light source would produce on a gently reflecting surface. But the highlight's too large. The sun is much smaller than that. It only occupies a very few degrees, or partial degrees, I don't know exactly, in the sky, but whatever, that blob is too big there. So if I go back into the material, I'll just get rid of that specularity, and what we'll do, just quickly, is go into the Skylab, go to image-based lighting, use HDRI, use Skydome only, and have a shot at converting this sky into a HDRI. Now, as things stand, the HDRI is only being used as a light source as default. It's disabled the sun, so if we just go render in scene, you can see things are looking dark. You can compensate for that by adding more light, but I'm mostly interested in the reflective effects, so I'm going to get rid of the effect on this, turn the quality down, and we're just looking at the reflection. Now, unless you use it as a background, it's not going to appear in the reflection, so let's use it as a background and add it to the sky. Okay, check out of here and have a look at the reflection. So the reflection is a bit darker, and we've lost the diffuse from the sun, but you can see, I hope, that we've got this highlight, and it's a much smaller highlight than the specular effect created, and that represents the brightness of the sun. So what you have here is a high dynamic range. You've got a sun that's very bright compared with the sky that's around it. And that's your advantage with high dynamic range. You see this preview, it looks like all this area of the sky is very bright. But that's because we're viewing this preview on a monitor, and a monitor can only display low dynamic range. To get some guides to how bright this sun is, turn the intensity down, and you can see now all these other things have just sort of faded away because they're more or less at the same level, but you can see the bright spot from the sun. So having a high dynamic range background where you've got high values that are beyond the range of your monitor to display it's a critical effect to achieve if you're going to have a good impression of reflection on objects, and this is why HDRI backgrounds work so well on reflective objects. So what I'm going to do is load in one of Horror's. I'll just load in this medium resolution one because we're only going to use it to provide reflection, and I'm going to take the intensity up. I think you've already got a hint from there because it's loaded in its old settings that these fluorescent lights are the brightest part. Now if I take this intensity up to say 10, and we check that it's added to the sky, and I'll just check out of here. What I'm going to do is I'm going to make sure the sky is set to fully black, so we're only adding in the HDRI backdrop. We've got no light output from this, so we're only looking at reflections at the moment, and I'll just give this a quick render. So here we're just having reflections. The reflections look really good. It should already be selling this render to you as being more realistic because of the reflective response on the material surface. I can throw in some additional lighting, so I'll just turn the sun back on so we're restoring ourselves to the original position, and you can see now that the diffuse is adding into the reflection here, but the reflections still look pretty intense. Now, if you're not convinced that the high dynamic background is actually contributing to this effect, then we can test this quite easily. What I'll do is I'll go into the Skylab, and here we've got this image. So you'd think, you know, I can just export this image using the exporter. I'll export it as a spherical map, map it around a sphere, light that sphere with ambient, and see what the effect is on the reflection. Before doing that, or after doing that, I'll do it afterwards. Okay, we'll just get the exporting out of the way before I forget. So if I change this to spherical map, I'm going to export it just as an ordinary bitmap image, and I'm going to call it for spherical map. Okay, that'll just take a little moment to export. I'll check out of here, and I'll just record this camera position and rotate the camera back, and we'll just have a look in a wider field of view what the background looks like at the moment. So what we're seeing there through the perspective camera on our low dynamic range monitor is an interpretation of the high dynamic range image that's providing those reflections. Remember, this reflective surface here is only 15% reflective. So if that was just full white as it is on the monitor, then it would just appear grey as initially the sun did when we rendered it in the normal Bryce sky. But what we've got here is fully white fluorescent light on the ceiling, and virtually, I've not tested it, but it looks about fully white on the surface of that material. So I'll just record this camera position so we can switch between these two. Go back to our object now. I'm going to create a default Bryce sphere. I'll give it a different family group so I can pick it out. I'm going to enlarge that sphere so it encompasses the entire scene. So you'll notice now things are looking a bit dark because the sun can't get through. I'm going to modify the material of this sphere. I can make sure it doesn't cast shadows, so that'll let some sunlight in. I'm going to get rid of the diffuse. I'm going to give it full ambient. I'm going to put in this blob here for the ambient a picture, and that picture is going to be the spherical map that I've just exported. There we go. Check out of there. Remember to switch it to spherical, because it automatically defaults to sinusoidal. So it's looking a bit dim, but the reason it's looking dim is that we've not provided the global ambient to drive this effect. So I'll just go to the sky and fog here and turn up the global ambient, so we've got some global ambient to drive this effect, and then render. Now, I hope you can immediately see that these reflections are looking a bit dim. It's not really got the impact that it had before. Now if I switch to my wide view, well, there is also, oh, there you go. This is the background on the sphere. It doesn't look radically different from the background that we had the HDRI image. I mean, I can demonstrate this. I can just hide the sphere. So I'll hide the sphere now and give that a render. Okay, so the orientation's changed. I can probably correct for that actually, if I think about it. I'll just have a, yeah, okay. If you want to do this correction, I'm going to point this out now because this isn't really tutorial, this is explanation. If you want to correct so your export is in the correct orientation, you need to take your exported spherical map, that's that, and then you go image and mirror image. No, it's not image, it's effect. Oh, I know it's in here somewhere. Offset. Okay, it's offset. In this case, I'm using PaintShop Pro, so it'll be different for different things. So if I switch to center, I should be able to offset it and then set the vertical offset to 0. So what I'm doing is I'm offsetting it exactly 180 degrees around. So if I go File, Save Copy As, and call this Converted. Okay, and go back to Bryce, go to the material for my sphere on the outside, select this new map, which I've done now, check out of there, still spherical mapped because I already sorted that problem out, and I will make that sphere visible. So I'll render that sphere now. So that is the sphere, and the reflections you can see are dull and unrealistic, and then if I go back to this sphere again and hide it, so and then render again, not any substantial difference in the appearance of the backdrop because the backdrop's low dynamic range image viewed through the monitor, but the reflections suddenly have a lot more punch. Right, now we'll move on to getting around some issues with this. It's great to have a high dynamic beige backdrop, but one problem is that your memory footprint for this can get quite large. This is a medium resolution one. I think that's about 4 megabytes. If you've got a large resolution one, which is ideal for having a background that you can see, then the memory footprint, because it's high dynamic range, it stores quite a lot of information. I think it's something like 96 bits per pixel as opposed to 8 bits per pixel with an ordinary bitmap image. Then it'll absorb about 34 megabytes on a large image, so there's quite an expense there. And the other thing is, you might want the lighting to be different from the image in the background, but the image in the background you're sort of stuck with, so you can't use this image to produce your high dynamic range backdrop, get your nice reflections, and then use a different image to provide better lighting that will be appropriate, because the thing about this is it's got very directional light sources, which under certain circumstances can create a lot of noise if you use the more advanced light simulation methods in Bryce, which is what I'm coming to now, bit by bit. So let's see what we're doing with this sphere. This sphere is hidden. That's good. Okay, I don't want to use that just yet, but I want to keep it around. Right, I'll switch back to my main view, give this a render. Now the thing to remember at the moment is that we've got no effect out of this. It's just the background that we're seeing added to the sky. What I'm going to do is switch render modes, go to premium effects. I'll select 4 rays per pixel, true ambience, scatter, correction, boost light. I'll lower the maximum ray depth. Okay, so that's a fairly standard setup. And now we've got a problem. All these fireflies. These fireflies are as a result of the background having very bright areas in it and the way that the light gathering method works. Now I'm going to turn the sun off for this because we're only going to use this light sources now. So the backdrop's just providing the light, and there's not enough because the backdrop's not bright enough, but the reflections are at about the right level. So because as a standard setting here we've got true ambience optimization, we can use the HDRI effect to create more light for the true ambience effect. So if I turn this up, we'll get a preview here, but that's not really a realistic reflection of what we're going to get, because this is true ambience rendering. So you can see now that's still looking noisy but rather bright, and I'll lower it to half that and give this a render. So maybe a bit dark. You just got to pick around in these figures a bit. Can't get a proper preview here. We can get a proper preview here. You have to select a little option here for accurate rendering, and then you'll see it gets very noisy. The noise can be contended with to a degree by using render options and increasing the rays per pixel. So if we take it up to 64, then we should get less noise. But if you've got very bright distinct light sources, because of the way the light gathering works, you need very high sampling rate. I'll try and explain. If this pixel under the cursor, let's say for example, so it's in the middle of a grey area which is uniform grey, so you would hope when it rendered it would come out a uniform grey, but this pixel, when the ray goes out to it, it's going to be sampled so many times. We know the sampling rate, we set that. So if a sample goes out, so if we're doing a low number of samples, 4, it makes it easier to explain. Sample goes out to here and it sees a dark bit of the background. And then another sample goes out and it sees a dark bit of the background. Another sample goes out, it sees this shape, and then moves on at random to somewhere else in the background and it's dark. And then it sees this, something like this, hits that very bright area there. That in turn leads to another bright area somewhere else, or somewhere on this geometry. But let's say it goes to the point where after so many steps it finds one of the very bright light sources in the background. If the other 3 were low but the other one's super duper bright, the average is going to be very bright. But if the light source is only small, the chances of the adjacent pixel seeing the same light source are low, which means that you will have light pixels, very light pixels, next to dark pixels that don't have a chance to see that very bright area of the HDRI backdrop. And the result of this eventually is noise, and this noise is ugly in the render. The solution is to have a backdrop that can have bright and dark areas in, but it's more uniform, which means that the chances of things seeing the areas of similar value are improved. So as your light becomes more uniform, you get less noise. I can demonstrate this. We can use this feature here. We can specular convolve the image. It takes a little while, and it'll always tend to produce an output image of a particular size, but it doesn't matter, because as you'll see, it's like a blurring effect on the HDRI image. So this is a feature that's built into Bryce, and what we're doing is we're taking the very small intense areas of light, and they're going to get spread and mixed in with the other areas, which as I say, is going to spread our probability of picking up light values that are more similar. And if they're more similar, then the average is going to be even more similar. And since we're dealing with a very uniform material here, the default grey, then the effect on that will be to smooth out the noise, which will improve our light situation. Now, bear in mind, what I'm talking about here is light and reflection, as dealing with them as two different things. But at the moment, the HDRI lighting is also our reflection. Right, okay, things have gone a bit dark there. That's normal. So I'll boost the output a bit more. Let's see if we can get it to a similar looking thing. Right, you can see what's happened with the background. So I'll just check out of here. Oh, that's gone way too light. Look at the preview there. Okay, I overcooked that too much. Let's try a lower level. Okay, right, that looks promising. So now, great. Look how much noise has gone. The fireflies have vanished. But by the same token, these materials no longer look particularly reflective. You can see a bit of the horizon there. You know they are reflective because I've not changed the material quality, the setting, the reflection. But we've got good even lighting, but poor reflection. So this is this problem that I'm finally going to get around to trying to explain one possible strategy for solving. What I want to do is provide even lighting and good reflection. So, as you might already be aware if you watched a few of my videos on obscure lighting, this is possible using that approach. So we'll do that first, and then we'll come back to a potentially more interesting solution. So what I'm going to do is reload the medium resolution HDRI image. That should be added to the sky so you can see the reflection there. And then I'm going to switch to light from inside, don't cast shadows, turn off true ambience optimization, include only background. This is an object that we're going to create. So what I will do is create a light source that's going to provide even lighting, because it's you'll see anyway. Right, that's probably the best way to do it, and you've probably seen it before anyway. Just make sure you've got your settings right and you've turned off true ambience optimization. You might need to apply to light source as a multiplier. So the light now is going to arrive from world center and spread outwards, and it's only going to hit one object, this object called background that I'm going to create, and we're not casting shadows because it's only going to light the inside of the object up. So we'll just create that situation. So I create a standard radial light, switch it to a different family just so I know what it is. Make sure I remember to name it background. It's got to be spelt right and capitalized. Modify the light settings. I don't need any diffuse output or specular output. It wants to be true ambience optimized. Use gel, procedural, reset to default. So this is the grey surface that the light's going to arrive on the inside of. I include only itself just to make sure it doesn't influence anything else. I'll just use side view and zoom out. So there's the big sphere. Don't worry about that. It's invisible at the moment. I'll just wrap this around the scene. Okay. So now if I render with this, I did it small so you can see the difference. We have got even lighting because it's a diffuse, and the simulated light sources generated at the world center spread out quite evenly on the diffuse inner surface of this light source, and then it's picked up by the true ambience effect and brought back in as a light source. So it looks quite similar to the specular convolved situation. It's coloured appropriately because the light that's been pushed out by the HDRI image is coloured. Then this is the edge of the light source. You can see now we've got this noisy zone because that's light that's arriving as a result of seeing this backdrop. We've got a backdrop that provides a nice reflection, and this potentially looks like a good solution. Well, it is a good solution. There are some drawbacks with it, because if we're going to see this background, I've only used the medium resolution one, but I want to show you this. You need a very high resolution image, and as I said, huge memory footprint. But it's okay for the reflections. So if we're only using reflections, we can use medium resolution image, and then we don't have the same problem with the background needing to be a high resolution if I'm going to see it. However, it's got me to thinking. I'm utilizing this light source, this radial light, to catch the light from inside, and that is doing the same effect as a specular convolved image. When Horo provides his light probes, he provides a specular convolved image which can provide very nice lighting. It's a shame. It's a shame that we can't have two images, an image for the background and an image for the lighting, to do these different things. Well, actually, the punchline to this is yes, that's possible within certain limitations. So that's what I want to look at next. You see this is working quite nicely, and the render time's not too bad. Okay, so I'm going to get rid of my obscure lighting light sphere, and we'll just try something else for a little experiment now. So if I get sphere here, which I've got this image mapped onto, and turn it back on so it's covering the scene up. So here we go, this is our low dynamic range image wrapped around the sphere. And then what I'm going to do is I'm going to turn that into background. So now that can be targeted by the light source. And then if I switch the diffuse on, I can light that up with the light source. So I've got the map of the image applied to that, and it's being lit by the light source. Is this going to work? I think you can see from the preview that it's not going to work. There's the limitation with the noise again. It's not bad, but it's not great, and the colour is somewhat lost. Oh, potentially then we could light it with just white. So, but I've set the atmosphere to fully white, and you see what we're doing here is this is background, so this is just a target for the light probe I'm going to create. So if I use the sky and create just fully white, I won't make it a sky dome, I'll make it a full sphere, and it's lighting from the inside, and it's targeted onto background, then I'll just have to check that we've got true ambience optimization disabled, because it turns it itself on by default. I can light that background evenly with white light, but because the image itself is low dynamic range, then the effect is not as appealing, and the reflections are not right, because they're just limited by the low dynamic range nature of those reflections. However, okay, right, I've been thinking about this. We have, right, the options. We could try and create a gamma compressed image of that same spherical map. Right, so we can create the same highlight effect. So this could be done in the paint package. Just brightness contrast, so we've got gamma correction here, that sort of effect. But even still, because this was low dynamic range before I brought it in here to process it, then the processing is limited by the fact that I've already provided it with degraded information. What I want to do is work with the high dynamic range information. Well, I could get HDR shop out and start fiddling with all the filters in there. That's tricky. I'm going to use Bryce, because Bryce has got a lot of control for HDRI, even for the limitations of an art software. I mean, it's only using it for lighting, but there's a lot of things we can do here. So I'm going to load in the medium resolution one, and I'm going to lower the intensity to 1. Okay, right, that looks really limiting. Yeah, and these look like dim, but they're not dim. They're a low dynamic range preview of the high dynamic range background. So if I export this image as a spherical map again, so here we go, so it's spherical. Let's see what we've got here. Yeah, we'll call this SM2. Okay, right, how is that going to look? Well, I'm going to adjust it again so that it's going to map right. I'll try and find it first. I'll put that one there. Okay, right. So that's what it looks like. I'm just load that in. Right, and then I've got to image mirror, and then it's effect, image effect offset, and it's remembered from last time, so that's done the rotation, file, save copy as, and that'll do me. Okay, right, go back into Bryce now, and I'm going to open Horo's Specular Convolved version of this. So now we've got the Specular Convolved image. I'll bring the intensity up to 10, and then we're still going to use obscure lighting in this, but I'm going to turn off True Ambience Optimization because it gets turned on again by default when we load this image in. So we've got this, which is Specular Convolved, and Horror's done that in a different application, so it doesn't look as soft, but it is softer, so that will provide some effect of directional lighting, but it'll also do something to mitigate the noise for us there. I'll just check out of here. That happens sometimes, I don't know why. Right, let's look at now material setting for this now. So this is our new spherical map I'm going to load in, that's just going to be looking like this. So this is just like the fluorescent lights. So there's our fluorescent lights. I'm not going to use diffuse, so I'm going to just use it in the ambient for reflection. It's spherical mapped, and I'll just give this a quick render, see where I've got to at the moment. I'll lower the rays per pixel for speed. Alright, bear with me. We've got full ambient output, and we've not got any light source in here. This is just reflection at the moment. I'm going to create a light source again. I'll create another radial light. So you can see at the moment the reflections are very dim. I can't provide enough ambient output to drive this material channel so these reflections show up. However, right, I can do that if I make an impossible output from the deep text editor. So it's a bit fiddly, but we'll go through it because it's important to see every step, I think, rather than me doing a Blue Peter and saying here's one I prepared earlier. So I'm starting with check blue. I'll go into the deep text editor, and this is the recipe we're going to use. We need to produce a positive output of a controlled level. So I'll start here with this one and open these dialogues up, go to noise. We need in this type here distance squared, which is right at the bottom. Minimum. So we'll just do minimum there. Octaves 1, and I need this frequency to be set to -1. It's already 3D, which is fine. Okay, so at the moment I'll just give alpha output there. You see this stripy output, that's a highly negative value. It can't be displayed properly in the deep text editor, and this needs to be processed to be positive. So if I take this over to the next channel here and use difference, and then modify this distance squared to nothing, drop the octaves, then the difference here, so this one is now nothing and this is the highly negative value, the difference between that on the output, although it looks the same, is highly positive. However, I want to bring it under some control. So if I take this empty one here, no, it's not, which one have I got here? I've got to find the right one, the empty one. If I take this one with nothing in and drag it over to the third component and use multiply, right, and then use a filter, a sine filter, I've done that in the first one, haven't I? Just pop that back again. Try and remember to do that in this final one. So use a sine filter again, and then what I need to do is take this filter down. Now watch the response here, so I'll flatten it out and then start lowering it down, and you're looking for when the stripes just start to spread out. So that is a positive value. It's out of the ordinary range, so it'll go over 100 ambient when I use it to control the channel, but it's lower, and I'll just lower it a bit further. So you see these stripes spread out, then that's good. So that's the situation you're aiming for here. Now look at the ambient response. It's driven very, very much over the level that it was before. You can see that it's pushed the colours out, so you're not getting strange response. So if we switch this to alpha scaling, we can dial it back until it looks more like it should do. The thing is, this, remember, is an export of a high dynamic range image, and what we got was like a gamma compressed response, which was very dim. Now we've brought the brightness of these lights up, possibly well beyond the ordinary range of ambient output, so we're going to get some stretching of the colours at the other end, because there's not enough information in a low dynamic range image to display high dynamic range, so you will have big steps. So that's what we're expecting to look for. But under this circumstance, we'll just give this a render. Let's have a look where we are with the reflections. Under this circumstance, you can see that the scene's getting lit because there's now something very bright in it, these light sources beyond the ordinary range. So we're getting decent looking reflections. The background, I'll switch to the other one that we prepared earlier. The background image now looks a bit funky. And the reason for this is that we've got values that got stretched out, and the JPEGing here is playing up. Well, you probably should export it in an uncompressed format, but you get the idea. We've got these very bright light sources. That's good reflections. Then it goes quite dark, and there's bands because we've stretched out high dynamic range, well, compressed high dynamic range image, and then stretched out the results to make it fit again. Let's sort the lighting out again now. So I'll create one of these radial light sources. Now, the key with this is we want to aim that it doesn't overlap with this other sphere, but is large. So I'll just create change family view, edit the light source, and just set it down as we did before. True ambience optimization, use gel, procedural, set to default grey, include only background. It's just so it doesn't see itself. Then modify the attributes to background so it can now become the target of the light source. Enlarge that so it's big but doesn't collide with the other sphere. We don't want anything like that happening. Switch back to my view, and I'll just go back into the image-based lighting and check my settings here. So we're lighting from the inside, we're not casting shadows, it isn't true ambience optimized. We've got a light multiplier here, so I'm going to put apply into light source so we multiply this up so we get enough light out, and it's including the background. So hopefully we get some light out of that. We don't get some light out of that. Possibly I've not got the include set correctly. Oh no, I've got the include set correctly. So what have I slipped up doing in this case? Something. It might need more light output. Right, so if I need more light output, I'll use 800. Okay, let's see if that brings us in. Nope, not getting anything now. Something is definitely a miss. Sometimes space in there. You see, it's critical that that's right. It's very easy to make that mistake, and now we've got loads of light. I thought it should have been about right at 100. Okay, set it back down again. Important lesson to learn there. So, okay, a bit dim. This edge, this transition, is as a result of not getting these spheres close enough to each other. But the gap between the two is the light arriving from the background, just providing light through the true ambience light gathering method. I'm going to pump this up a little bit further. So, yes, this has gone on quite a bit as well, which I apologise for. Right, so now the situation is we've got the Specular Convolved image driving the effect in the obscure lighting effect, but the reflection is provided by this background image that's provided, this nice reflection effect, and is being driven up to a comparable level of brightness for the HDRI due to being able to take advantage of, I'll get this other one, I'd turn it not to background and then outer sphere we'll call it. Then it won't become the target of the light source as well. So we're using this cheeky extreme material response here to create this effect. I'll try a lower value, so maybe it'll just pick up the fluorescent lights better. And the export options of Bryce. So I really like this idea because it uses so many of Bryce's features, the things that it's got an advantage on. So what I'm going to do now is make sure that the background isn't in shot. So we're only dealing with the reflections. And you can see that the ground's fairly even. Remember, we're looking for a fairly diffuse lighting. If you throw in the lighting from the sun, for example, let's turn the sun back on, which is possible, then you would have an area of distinct shadow. You could soften those shadows, and it would also reduce the effect of the noise, and you would get specular stimulation for materials that had specular response in. So do consider doing that when you're using materials that have been set up to take advantage of specular response. You don't have to give diffuse output. You can just get those responses. I'm not going to do that here. I'm just going to remind you that it's possible. What I'm going to do here is the challenge of trying to get just the output right using obscure lighting, HDRI effects, and this reflection. I've not done a full render using this, so I've just got too much light there. And so this is a proper experiment. It's just that idea occurred to me, and I thought I'd have a go. And here we've got to this point. Right, so what's our raise per pixel? If I turn this up to 256, that's going to be the most sampling we can have beyond actually doubling the size of the image and then shrinking it down later to get more equivalent of sampling. So how's this going to look, and what's the render time going to be like? This is the questions, the critical questions. So about quarter of an hour actually about half the time it's taken me to record this video. So what I'll do is we'll let that render out, and then we'll have a look at the results and see whether this is a process worth pursuing. Okay then, let's see how it turns out. Here then is the final rendered image and a little bit of a recap. So what we have here is obscure lighting driven by a specular convolved HDRI created by Horo, and the reflection being driven through extreme ambient material response on an exported version of that HDRI that wasn't specular convolved, medium resolution one. So essentially this offers the capability to render an image with the reflection from one HDRI image and the lighting from another, but both having the advantage of HDRI images. So we're still getting the good reflective qualities that I was really looking for. So there you go. Hope you found that interesting. That's the end of the video.